In this video, we're going to have a look at the physical properties of a number of compounds. And as you can see in your workbook, it says identification of a compound with the aim to perform, observe and record tests on the physical properties of compounds. And secondly, to identify 2 of the 6 white unknown solid compounds. So that's what we're looking at. Now, the compounds that we're looking at, as you can see listed in your workbook, are, to begin with, calcium carbonate, cooking salt, table sugar, sodium carbonate, decahydrate, wax, ammonium chloride. So these are the substances that we're looking at. So the physical properties that we're going to be looking at are, first of all, the appearance, the colour, the lustre or shine, whether they are in the form of crystals or flakes, and the size of the particles. So that's their appearance. Now, the other things that we're going to be looking at are the relative melting points, the behaviour on strong heating, the smell or odour, their solubility in water, and whether or not they will conduct an electric current in solution. So let's begin by having a look at calcium carbonate and its appearance. So this is the calcium carbonate, and I'm using a spatula to take a sample out from the container. And when we have a look at that, so the first question is the colour. Well, could I suggest white? Secondly, does it have a shine or a lustre? Can I suggest no? Is it in the form of crystals or flakes or a powder? It looks much more like a powder, I would say. If I was looking for crystals, I can't see any shiny surfaces. So I'd describe this as a white powder. Let's have a look at the next one, which is sodium chloride. So first of all, its colour. Again, might I suggest white? Secondly, does it have a lustre? Well, you might be able to see that the crystals have got a bit of a shine on them. You can see as I turn it a little bit, occasionally some of the crystals will reflect back a little bit of light. So you can see a little bit of a shine on some of the crystals, but we wouldn't describe that as lustre, really. When we're looking at lustre, we're really looking at the shine that we see on metals. So as far as the crystals are concerned, you might be able to see that, yes, there are crystals there. So we'd say a crystalline solid, a white crystalline solid. Let's have a look at the next one. Our next one now, as you can see, is sugar. Colour, again, might I suggest white? Does it have a lustre? Well, no, it doesn't, even though you can see that it is made of crystals, and those crystals are reflecting light, indicating a shiny surface. But not really, we don't describe crystals as having a lustre. Next compound. So this one is sodium carbonate decahydrate. The decahydrate means that each group of atoms of sodium carbonate is surrounded by 10 molecules of water, and they enable it to form normally a crystal. So having a look at sodium carbonate, Decahydrate. First of all, we can say its colour is white. Now, does it have crystals? If we just move some of these a little bit about, we can't see those shiny surfaces. So I'm not going to say that it is made up of crystals. No. Apart from that, does it have a luster? No. So I would describe this as flaky. Okay, little bits, indefinite shapes. There's no definite six-sided shapes which go to make it up. So I wouldn't describe it as crystalline. The next substance for us to have a look at is wax. Now, you are familiar with wax from candles. So just taking a small sample of wax. Again, describing its colour. Seems to be white again. Does it have a luster? No, it doesn't really have a shine. What else about it? Is it flaky or crystalline? I'd describe that as flaky. Let's have a look at the next one. The next one is ammonium chloride. So taking a small sample of that with our spatula. As far as the colour is concerned, I don't think there's too much doubt about that. I think we could describe that as white. What else? Does it have a luster? No, not really. It does have the shiny surfaces because I think you can see that that is crystalline. Small crystals there. So small crystals is how, and white is how we can describe this. Let's have a look now at the next set of properties, which is their relative melting points. So once again, we'll get a small sample of our calcium carbonate, I'll place that on top of a candle flame. Just spread it out a bit to see if anything is going to happen to it. Of course, the candle flame has got a low temperature. So at this stage, no, there's nothing happening there. I've got my Bunsen burner here, which is on, well, it's close to anyway, a safety flame. And you can see the yellow there. So what I'm going to do is turn that on to high heat and put it in at the top of the flame there where it is hottest. At this stage, the spatula is very, very close to being red hot, and there seems to be no change at all in the calcium carbonate. So I'm going to say the calcium carbonate has a relatively high melting point. I'll just let that cool down and I'll turn the safety flame back on. The next one for us to have a look at is the sodium chloride, our table salt. So we'll have a look at its melting point. First of all, into the candle flame. So even after a few minutes, I can't get any change in its appearance. So now I'll try the Bunsen burner. Some crystals there are certainly bouncing around. But the question is there any melting occurring? Again, now it's very, very close to being red hot. So it didn't melt in the candle flame, it didn't melt in the Bunsen flame, so I'm going to say high melting point. The next one that we're going to have a look at is sugar. So I'll take a small sample of the sugar. Put that in the candle flame. So there doesn't appear to be any change in a candle flame, so I'll put it into a Bunsen flame. Oh, and you can see there that it is melting. And not only that, it is starting to burn. Quite vigorously, actually. So it's left some carbon there, and the water that goes to make up the carbohydrate has been driven off, and I can smell it. It certainly has a smell. So let's have a look now at our sodium carbonate decahydrate. So this now is our sodium carbonate decahydrate. First of all in the candle flame. Now there does seem to be some change there, and you can see that it is melting. And might I suggest that what is happening there is that the water of crystallization is now enabling that to dissolve as a little bit of a solution, and that water might be driven off as a gas. Just let that settle for a moment. I don't know if you notice there a little bit whiff of vapour or coming off, and now it seems to have settled down a bit. Still perhaps some boiling occurring, or water being driven off. So in terms of physical property, how will we describe that? Let's call that melting, or perhaps better still, let's call it dissolving. What I'll try now is putting this into the Bunsen flame. See how it goes. Perhaps it's becoming a little bit whiter, and maybe a little bit of that water is still being driven off. But as you can see, it is not really changing into a liquid. And the spoon is, or the spatula is almost red hot again, and still we're getting no change. So what we've done there is simply driven off the water. So instead of writing melting, it would be better to say that it did some dissolving and then recrystallised, although the crystals would be very, very small. All right, let's try the next one. This next one is wax. So putting the wax into the candle flame. Now, it might not surprise anybody that we can see that that is melting. So we would say that wax has a low melting point. There's no need to put it into the Bunsen burner, flame, in order to see if it has a high melting point. Obviously, it has a low melting point. The last one for us to look at is the ammonium chloride. So taking a small sample of that, putting that into the candle flame. There doesn't seem to be any obvious change there. So I'll try the Bunsen flame. We can see certain change there now. We're actually getting some smoke coming off. Don't know if you can see that on the video. You can, yes. And at this stage now, it's pretty well all gone. So what's happened there? In fact, what's happened is that it's been hot enough not just to melt, but to undergo a chemical change. And what's happened is that the ammonium chloride has broken down into ammonia, a gas, and hydrogen chloride, another gas, and so off it's gone. So what you could say for that one is high melting point. Now the next thing for us to look at is its behaviour on strong heating. What we've actually done so far is really answered that question. So the question there, is there smoke or a change in colour? If we go back to those situations in which we put the substance into a Bunsen flame, then you can see the behaviour on strong heating. So there was no change for calcium carbonate, there was no change for ammonium chloride with the table sugar. That table sugar broke down to give carbon, that black material that we saw. With the sodium carbonate decahydrate, we saw the crystals or the sodium carbonate dissolve first of all, then release its water and form simply sodium carbonate. So its behaviour on heating is simply to release the water. With the wax, we did not put that into the Bunsen burner, so I'll just give that a try. We'll see what happens. So I've got some wax now on this spatula. I'll put those into the flame. We would expect the wax to melt, which is what is happening now, and you can probably see that. So we'll try heating it now really strongly. You might be able to guess what's going to happen, and there it is, it's happening. How would we describe that? Well, we would say that it burns. Simple as that. Now the next thing for us to look at is its behaviour on strong heating. What we've actually done so far is really answered that question. So the question there, is there smoke or a change in colour? If we go back to those situations in which we put the substance into a Bunsen flame, then you can see the behaviour on strong heating. So there was no change for calcium carbonate, there was no change for ammonium chloride with the table sugar. That table sugar broke down to give carbon, that black material that we saw. With the sodium carbonate decahydrate, we saw the crystals or the sodium carbonate dissolve first of all, then release its water and form simply sodium carbonate. So its behaviour on heating is simply to release the water. With the wax, we did not put that into the Bunsen burner, so I'll just give that a try. We'll see what happens. So I've got some wax now on this spatula. I'll put those into the flame. We would expect the wax to melt, which is what is happening now, and you can probably see that. So we'll try heating it now really strongly. You might be able to guess what's going to happen, and there it is, it's happening. How would we describe that? Well, we would say that it burns. Simple as that. The next physical property that we're looking at is odor. Now, another word for odor is smell. Smell is a verb as well as a noun. Odor is a noun. So anyway, to just check out the smell, the odor of this, I'll just put this up our nose and wave some air towards my nose, and no, we don't have any. Again, if I take the sodium chloride and hold that up towards my nose and waft some air towards my nose. No, I can't smell anything, so no odour. Another way we can describe that is odourless. Looking at the sugar, again, sugar is odourless, doesn't have a smell. Sodium carbonate, Decahydrate. No smell. Wax. Perhaps a very slight smell. The last one, ammonium chloride. No odour, so odourless. The next physical property is solubility in water. Does it dissolve in water? Or some dissolved or did not seem to dissolve. In other words, we would describe it as insoluble. So let's try first of all our calcium carbonate. So I have here a test tube partly filled with water, and what I will do is add the calcium carbonate. We'll see what happens. That's probably all I need to add. No, I'll add a bit more. I'll do this over the sink. So there it is there. I'll tap the side of the test tube like this to try and get it to dissolve. Now I'm not too sure if you can see down the bottom of the tube. It seems to have settled or be settling. So my suggestion there is to write that it does not dissolve. Now, if you said, how do I know that a little bit doesn't dissolve? Well, I would say at this stage, I don't know. But I am aware that calcium carbonate is not soluble in water. So I would say, did not dissolve. Our next test is for sodium chloride. I'll give it a shake. Now I'm shaking it this way because this is a safe way of shaking chemicals in test tubes. To put my finger over the top here and then shake it up and down is not good practice in chemistry. Why? Because you could have contaminants there on a dirty finger. Dirty finger. So if you have a look at that, I think it's fair to say that it dissolved. You can see that there's a little bit there that is not dissolved. It's a little bit milky, but my answer would be sodium chloride dissolves in water. It is soluble. The next one that we want to have a look at is sugar. You might know the answer to this already. Right, there's still a little bit down the bottom there, but I think it's fairly safe to say that sugar dissolves. So let's have a look at the next one. So this now is our sodium carbonate decahydrate. So we'll take a small sample of that. I think you could probably say that a fair bit of that dissolved. Let's give it a little bit more of a shake. So there are a few crystals there that are still remaining. And at this stage, it looks as if it's almost entirely dissolved. So we'd say sodium carbonate decahydrate is soluble in water. Having a look now at wax. That doesn't look as if it's dissolved at all. All right, so did not dissolve, or insoluble. Finally now, our ammonium chloride. I'll just take a small sample. There's a few crystals down the bottom there. I'll give the test tube a shake. See if we can see any crystals. And it seems that they've all disappeared. So we can write soluble or dissolved. Our last task now is to check for conductivity of a solution, yes or no. Now, in order to do that, what I've got is a piece of equipment here, and this equipment is connected to a power supply. So the power supply you can see here. So the electricity will run through this, through the solution if it is a conductor, and then it will light up this bulb, this globe, if it is a conductor. So the first one that we'll try is our solution, or try and make a solution of calcium carbonate. Well, we did find that calcium carbonate was insoluble, so we'll just see what happens when we try its conductivity. So this next one is sodium chloride, and we saw that that dissolved earlier on, so I'll put that into the sodium chloride. And you can see, I hope, that that lights up. So yes, sodium chloride is a solution that conducts. Right, let's test, Sugar, now, as we know, sugar dissolves. I'll put a little bit of sugar in to make a solution. Give it a shake to make sure a fair bit of it has dissolved. Put the electrodes into the sugar solution. Have a look at the globe. Doesn't seem to be lighting up. So our sugar solution is a non-conductor. No is our answer there. Let's try now our sodium carbonate decahydrate. Now, we saw that this dissolved a little bit at least last time. Now let's see what's going to happen now. After giving this a little bit of a shake to make sure that some of it has dissolved. Yeah, a lot of that has dissolved. Let's add our electrodes. Now you should be able to see that the globe there has become a light. So yes, this is a conducting solution. Sodium carbonate, decahydrate. Yes, a conductor. The next one is wax. Well, as we saw earlier, the wax doesn't dissolve, so even if I try to put in a little bit, you might be expecting the results. Okay, so there it is, and our wax is floating there on the top of the water. So if I put the electrodes in, and have a look at the globe, it's not lighting. Non-conductor. No is our answer. Now, our last one to test is ammonium chloride. So we'll take a small sample of ammonium chloride, add this to our water, give it a shake. Check to see that it is dissolving. Take a bit more. Okay, so it's all dissolved there, most of it. So we'll add our electrodes. Oh, that's lovely and bright. So certainly here our ammonium chloride is a conductor in solution. Now the task is to identify some of these unknowns. Our task now is to identify some of these unknowns. I've got several unknowns here. Unknown A, unknown B, unknown C. You might be able to guess the next one, unknown D, unknown E, and finally unknown F. So our task now is to try and work out which one of our known substances these unknowns are. We'll have to have a look at their physical properties.